Hi students, this is your Shiva and you are watching Shiva's Maths Library. In this video, we are going to see our second chapter, that is Introduction to Linear Polynomials. Here in that introduction part, they have given the introduction to the concept of linear polynomial, where we are going to learn about the concept of algebraic expression first. So basically in our earlier classes, we have studied about algebraic expression, an expression which contains variable and constant terms is called an algebraic expression. In our lower classes, we used to study that algebraic expressions are of the form some 3x plus 5 or 4y minus 7. Okay, so here x and y are called variables and 5 7 are called constant. So a combination of both variable and a constant is called an algebraic expression. Here we are going to study a special type of algebraic expression called a linear polynomial. Okay, so to understand the concept of linear polynomial, they've started with an example. So in this example 1, they've mentioned that Raju went to a shop where there were sealed boxes of different colors on sale. The shop owner told him that the red boxes have 4 pens each and blue boxes have 5 pencils each. Now, if Raju bought X red boxes and Y blue boxes, how can he quickly figure out the total quantity of pen and pencil? Also, if we get 3 extra pens free, how many pens and pencil did we get together? So basically, what they have given is the shop owner told him that the red boxes have 4 pens each and the blue box have 5 pencils each. As they are given in the picture, we can able to see there are 4 pens and also 5 pencils are there. So he is saying that he bought X red boxes and Y blue boxes. We don't know how the number, it can be 1 or 2 or 3, and also this can be 1 or 2 or 3. Okay, so depends upon this x and y concept, we have to find out quickly the total quantity of pen and pencil if he is having. And one more thing is, they've mentioned that he got 3 extra pens free. So suppose, let's consider the situation that he bought only one box. In that case, one red box. Okay, so this is red box. In that case, he will be having total of 4 pens. Suppose if he bought 2 red box, he will be having 8. If he bought 3, then he will be having 12. So which are nothing but 4 into 1, 4 into 2, 4 into 3. So this is nothing but we are multiplying this value into 4. So 4 ones are 4, 4 twos are 8, and 4 threes are 12. So generally, the total number of pens in that particular box can be identified by multiplying this value into 4. If I bought only one box, 4 ones are 4. So I will be having 4 pens. If I bought 10 box, then 4 into 10, I will be having 40 pens. So 4x is the expression which used to determine how many pens are there in the red box. Similarly, in this pencil box, we are having 5 quantities. If I bought only in the blue box, if I bought only one box, I'll be having 5 pencil. If I bought 2 box, I will be having 10. If I have 4 box, I will be having 20. So this value will be multiplied by 5. So the 5 ones are 5, 5 twos are 10, 5 fours are 20. So this is 5 into y. So by multiplying this 4 and 5, the number of pens and pencils in each boxes are containing, we are multiplying it with our variable x and y together, so that we are having a term called 4x representing the total number of pens and 5y representing the total number of pencil. In addition to that, since he is getting 3 extra pens, so 4x plus 5y plus 3 is the expression which exactly depict the total quantity of pens and pencil is having. Okay, so this is what given in the next line. Observe that x red boxes will have 4x pens. See, x red boxes will have 4x pens and y blue boxes will have 5y pencil and extra 3 pens free. So they have added all the values and the algebraic expression is given as 4x plus 5y plus 3. So this is what we are getting with our idea. In this example, this values 4x and 5y and 3, where 4x is the total number of red pens, 5y is the total number of pencil, and 3 extra pens they have given free, right? So all these 3 individual values are called as terms of the expression. Okay, suppose if you are having an expression, the individual values are called as terms. So x and y are the variables and there are number 4 and 5 which are there in front of this x and y. So these values are called as coefficient of x and y. In our previous example, look at here the example for this example. Here we are having 3 as a value in front of x. So this is called coefficient of x. Here in front of y we are having 4. So 4 is the coefficient of y. So wherever we are having variable, the number which is there in front of the variable is called coefficient. So here the coefficient are 4 and 5 because we are having 4 and 5 in front of x and y. And the term which is free of variable is called a constant. So here there is only one term called 3. So we are going to call that 3 as a constant term. From now onwards, we will use a widely used alternate word for letters called variable. So we are going to call the x and y letters as variables here. As I mentioned earlier, the one which is getting varied is called a variable. Thus, in this expression 4x and 5y plus 3, we can say that the variables are x and y because it is getting varied. I can buy 2 boxes, I can buy 10 boxes, I can buy 50 boxes of pencil or pen. So this is getting varied, but 4 and 5 are fixed. So we are calling this x and y letters as variable here. In our next example, a rectangular garden of length L meters and width W meters has to be fenced and decorated. A wire fence is to be laid along the length costing rupees 100 per meter square, and a wooden fence is to be built along the width of costing 80 per meter square. A special seat to be shown throughout the garden which will cost rupees 50 per meter square. So what we are supposed to find here is what will be the total cost incurred. So basically they ask us, they have given that a rectangular garden of length L meters and width W meters, okay, has to be fenced and decorated. First, a wire fence is to be laid along the length costing rupees 100 per meter. So for each length area they are using a wire fence whose cost is rupees 100 per meter. Since we are having L meter, we have to multiple the value into 100 because if we are having a rectangular garden of 10 meters, then for each meter we have to spend 100 rupees. So if it is 10 meters means, so 10 into 100 we have to spend. So 10 into 100 we have to spend rupees 1000. Okay, rupees 1000. Since here we are having L meter, so L into 100 it will be 100 L. So this is the amount that we need to spend for the length. Similarly for width, wooden fence is used to build along the width. So here they are using wire fence for length and wooden fence for width. Okay, see here, this area they are using wire and this area they are using wooden width. Okay, so wooden fence. So this will cost rupees 80 per meter and we are having W meters. Similarly, so its W meters of rupees 80 would be 80 W. So this cost is for length and this cost is for width. So cost of width and the cost of length are given by 100L and 80W. Okay, and the last one is a special seats has to be shown throughout the garden which will cost rupees 50 per square meter. If I want to show this special seed, first I need to find the area of this rectangular part. As we know that the area of rectangle is length into breadth. Here length is L and breadth is W. So first of all we need to multiple the value of length and the breadth here. So L into W is the area and each area is costing rupees 50 per square meter. So it is going to be cost of this area is going to be 50 into LW. So this is our next variable. Okay, so third one. So the total cost we can able to identify by using the values which we identified in the above cases. So here we are having fence in both the sides, both the opposite sides of this rectangular parking park area. So here we are using 100L. Similarly here we have to use rupees 100L. So 100 plus 100 it is going to be 200 in total. Okay, so that is how they have given the cost of wire fencing along the garden is 2 into 100L, it is 200L. Similarly here we know that for one side width we have to spend rupees 80 into W. So for both the sides it is 2 into 80, it is 160. So we have to spend rupees 160 W. Similarly for this area we know that cost of uh, that shown seats is 50 LW, right? So we have to add this also. So the total cost is 200L 160W and 50LW. So this is an expression which depicts the total cost of the above situation. Now in this case, what they are asking is, can you identify the term, variable and the coefficient of this algebraic expression? Yes, there are three terms. One is 200L and another one is 160W and another one is 50LW. And what are the variables they are asking? Since there is two letters, one is L and W, we know that the variables are L and W. So we are having three terms and the variables are L and W. What are the coefficient of this algebraic expression? So coefficient is nothing but the numbers which are in front of the variable. So here 200 is there. So 200 is the coefficient of L, and 160 is the coefficient of W, and 50 is the coefficient of LW. Okay, so in the next question, how it is different from the algebraic expression in example 1. In the example 1, we are having an expression like 4x plus 5y plus 3. So here the algebraic expression is 200L plus 160W plus 50LW. The major difference is both the terms, both the expression have three terms, but here we are having two variables and one constant. Here there is no constant term. So the major difference is there is no constant term. There is no constant when we are comparing with the first one. And the case 2 is, here the two variables are getting multiplied in the third term, but here there is no such thing. So they are asking about only one difference. So you can simply say that there is no constant term here when we are comparing with equation number algebraic expression in the example 1. Okay, so in the third example, they are saying that a wire of length 20 centimeter is bent in different ways to form a rectangle. So initially they are having a wire of length 20 centimeter. Now they are bent it into a rectangle shape. Now for example, if we can have a rectangle of length 7 centimeter and width 3 centimeter. If length is 7 and width is 3, then we will get this 20 centimeter. As this opposite sides are equal, this should be 7 and this should be 3. So 7 plus 3 10, 10 plus 7 17, 17 plus 3 20. So we are getting this 20 centimeter. So basically how they are deciding this L and the B value is, we know that the perimeter of rectangle is 2 times of L plus B. So here since they are giving it as 20, so L plus B must be equal to 10. So whatever the value you are taking for L, it has to be subtracted from 10. Suppose if I take length as 7, so 10 minus 7 is 3. That should be the breadth value. If I am taking length as 5, what is 10 minus 5? 5. So breadth should be 5. If I am taking this as 4, then this has to be 6. So that the sum should be 10. So here what they have taken is, if they take 7 centimeter, then the width should be 3. We can also take one length is 5.5 and width is 4.5. So that is what we are getting from this expression. Can you write an expression for the area of a rectangle? So here they are asking about the area of a rectangle. Basically we don't know, they can make a different rectangle with a different length and breadth value. As we mentioned that 3 and 7 and 5.5 4, they can take 6 and 4 also, 1 and 9 also. Okay, it can be varied based on their length and breadth value. So what they need is, I don't know the value. The values which are varying, getting varied is called variable, right? So I'm going to assume that the length has to be x units. If I'm choosing the length value as x, we know about the rule of breadth. Breadth has to be subtracted. Breadth can be obtained by subtracting length from 10, right? See, if I'm choosing the length value as 7, then 10 minus 7 is 3. That is our breadth value. Similarly, if I'm choosing the length value as 4, 10 minus 4 is 6, so breadth has to be 6. So similarly, if I am choosing the length value as x unit, then breadth must be 10 minus x. Okay, so by using these two terms, we are going to find the rectangle, area of rectangle. As you know that length is x and breadth is 10 minus x, we know the area of rectangle formula. Area of rectangle is L into B, length value is x and breadth value is 10 minus x. So it has to be 10x minus x square. Once you open the bracket, you will get an expression like this. Look at here, if the length of the rectangle is x centimeter, then the width must be 10 minus x. This is the reason. So that the sum should be 10. The expression of this area could be this rectangle is x into 10 minus x, that is length and into breadth. So we are getting 10x minus x square. Can you identify the terms, variables and the coefficient of this algebraic expression? Yes, we can able to identify. There are two terms and the variable is simply x. and x square are the variables, and moreover, no, the variable is x square is not a variable is only x. Okay, x square is a term, we are having x term and x square term. Okay, coefficients are coefficient of x is 10 and the coefficient of x square is -1 is the coefficient of x square here. Okay, of this algebraic expression. Can you point out any similarity or difference between algebraic expressions obtained in example 1 and 2? Yes, there is a difference, major difference is there, because in example 2 and example 1, okay, we are having two variables, there is more than one variables are there, x and y are there, here L and B are there, L and W are there, but here we are having only one variable called x, but in different form, x and x square. Okay, but the variable is same, only one variable, that is nothing but x. Okay, that is a major difference, we are having only one variable compared with example 1 and 2. And another major difference is there is no constant term when we are comparing equation number 1 and equation number 3 that we are having in example 3, there is no constant term here. And yeah, that's all. Okay, so by using this, note the algebraic expression in example 1 and example 2 involving two variables. So this is what I mentioned. Okay, so in 1 and 2 we are having two variables, one is xy and another one is lw, but here we are having only one variable called x, whereas the algebraic expression in example 3 has only one variable, correct, that is x. Okay, so expressions such as 4x, x square plus 1, 2y, 5y cube plus y square, 2y, or 3z plus s are examples which involves only one variables x, y, and z. See, in all the examples, this 4x, it has only one variable x. This term x square plus 1 has only one variable x. This has only one variable y, and this has only one variable y. But there are three terms, but all the terms are in the form of y, right? Y cube, y square, y. So similarly here we are having z. So in this chapter we will restrict our discussion to algebraic expression involving only one variable, because initially they have said that we are going to study about a special case called a linear polynomial, right? So a polynomial or an algebraic expression which involves only one variable is called a linear polynomial. So that is what they are restricting their expression to, only one variable. You may notice that the algebraic expression, the powers of the variable also appears. For example, in the algebraic expression x square plus 5x plus 1, the highest power of x is 2. Whereas in the expression 5x cube plus y square minus 8, the highest power of the variable is 3. Okay, further in the expression 5y cube, the coefficient of y cube is 5. That is, y square is 1 and that of y is 2. And the constant term is minus 1. Such expression, algebraic expression involving one variable and its powers are called a one variable polynomial or univariate polynomial. Okay, so all these examples, this one and this one, are called a one variable polynomial because there are many terms, but it involves only one variable. Okay, so when the context is clear, simply polynomials. Okay, so the highest power of the polynomial is called the degree of the polynomial. This term is very important. See here, they are saying that the highest power of a variable y is 3, the highest power of the variable y is 3, or the highest variable here in this expression, the highest power of x is 2. So instead of using the word highest power, they are restricting the term called degree. So whenever they are asking a question like what is the degree of this expression, we have to search for the highest power. So highest power means degree, degree means highest power here. Okay, so based on the degree they are defining different polynomials here. So in this polynomial we know that the highest power is 3, so the degree is 3. Such polynomials are called as cubic polynomials. So the polynomial whose degree is 3 is called a cubic polynomial. Similarly, in this polynomial the highest power is 2, so the degree is 2. Such polynomials are called as quadratic polynomial. So degree 2 means quadratic, degree 3 means it's cubic. So here it's 3z plus 7, where the degree is, highest degree is 1. Highest degree is 1 or highest power is 1. So such polynomials are called a linear polynomial. The constant 8 is a polynomial of degree 0. This is a very important statement. Okay, so whenever we are having a constant, okay, whatever the constant may be, let us assume the constant may be k. If someone asked what is the degree of constant, degree of constant polynomial, mean the answer is 0. So degree of a constant polynomial is always 0. That is our answer. And the polynomials and each constants can be called as constant polynomials also. Okay.